Bismillahirrahmanirrahim. Assalamu alaikum. I am Sayyid Akif Shah, lecturer finance at Institute of Business Studies, Kohat University of Science and Technology. The title of this course is Business Finance, and the course code for this subject is BS 151. This is lecture number 20th, and the topic under this lecture discussion is risk and return. The outline of this lecture comprises of the definition of risk and return. Then we'll discuss using probability distribution to measure risk or dispersion. And the third topic for discussion will be the formula used for measuring risk and return for continuous data. Dear student, after listening to this lecture, I assume that you should be able to understand, are able to define, are able to learn the following two outcomes. Number first, to understand risk and return nexus, and secondly, understand how to measure expected return and standard deviation, which is measure of risk, and coefficient of variation, which is a relative measure of risk. The definition of the return has already been covered in my previous lecture. However, as a recap, I can narrate it that it is the income received on an investment plus any change in the market price, usually expressed as a percentage of the beginning market price of the investment. And we have used this formula to calculate the return on investment opportunity. We have selected stock investment to find out the return on that particular investment opportunity. Then we have covered how to calculate the expected return using a discrete distribution, which is not in the decimal places. The formula used for calculating the expected return was R bar is equal to summation I start from 1 into n, then multiply the R return possibility, ith possibility, multiply by with the PI, which is the probability of occurrence of that specific outcome. So this was the calculation or the slide where we have left our discussion in the previous lecture. It is stock of basket wonder, and the data regarding the possible return and the probability associated with each outcome was given, and we were expected to find out, we were desired to find out the expected return of this stock portfolio. Not portfolio, this is stock investment, which is stock of basket wonder, since we have opted only a single share to invest in, and its possibility and relevant data regarding the return and the probability is in the first and second column. And then we have calculated this expected return, which is 9% on the investment of stock of basket wonder. Now here we will start with the calculation of the risk factor, as we have already calculated the return and expected return. So therefore, for a discrete data, how to calculate the standard deviation? The formula to calculate the standard deviation is before you, but before explaining the formula, let us explain the standard deviation, which has been denoted by this sigma sign. Standard deviation is a statistical measure of variability of a distribution around its mean. Basically, standard deviation covers and discuss about the dispersion of the data from the mean value. Let's say if a class has 10 number of students, and the mean or average score obtained in the statistic course is, let's say, 65, then it is not necessary that all the 10 students will or might have obtained 65 marks. Definitely there will be variability in the marks obtained by different students. So one student might be on 85 marks, the other one could be on 55 marks, the third one may be on 70 marks, and the average marks, which is the mean obtained by this class, was 65. So therefore, the dispersion or the deviation from the mean score obtained in a statistical class is known as dispersion or variability around its mean. When this dispersion has been calculated in respect of percentage, it is known as standard deviation. And the formula for calculation standard deviation is in this rectangular yellow box. However, as we are discussing financial management or business finance particularly, and therefore we have already started the discussion of risk and return in the context of share investment. Therefore, we will talk about the standard deviation in this scenario here onward. The sigma denotes standard deviation, which is equal to under the root and then summation start from 1 into the n. N represents the number of possibilities of different returns. This Ri represents the ith possible return, and this R bar represents our expected return on that stock where we have invested. As we have explained in the previous slide and as well as in my previous lecture, we have in detail discussed about the calculation of the expected return, which was 9 in our case. The Dist data has come up with 9% of expected return if the investor is going to invest his money in the stock basket wonders. So therefore, this R represents the expected rate of return, and then a bracket sign starts with the power of 2 raised to the power 2. So you need to minus or subtract expected return from each possible return, and then at the end you are supposed to multiply it with the relevant probability or the possibility of that outcome. We will discuss a solid example to calculate this standard deviation shortly. Already explained the standard deviation. It is the square root of the variance. We can also say that if we remove this square root, the resultant value represents the sigma square, and this resultant value depicts the variance of that particular stock. And remember, we have taken this example and formula for a discrete distribution, not for the continuous distribution. What is the difference between discrete and continuous? The data may be discrete one or the continuous one. The example of discrete data is the number of students in a particular class. Like those number of students may be 10 in number, those number of students could be 50 in number, but the number of students in a particular class cannot be between 10 and 11, and similarly those cannot be between 50 and 51. There must be, those number of students must be solid one, and those must be in full numerical value, like 10 students, 15 students, or 50 students. But it doesn't make sense to say that number of students in a class are 50.5. This 0.5 doesn't make any sense. So when a particular data is a kind of nature where a complete solid values should be there, that data is known as discrete. Let's take another example, like result of rolling two dice. So one dice may have 4 outcome and another dice might be having 2 outcome, and we can accumulate both the results of the dice, and the resultant value is 6. Now such kind of data is known as discrete data. What is a continuous data? Continuous data is, let us take an example, height of a person. So height of a person is not necessarily to be 5 feet or 6 feet. It could be between 5 and 6 and maybe greater than 6 as well. So when the numerical value can be in decimal places like 5.3 feet or 6.1 feet, then such kind of data is known as continuous data. Similarly, share price of a company's stock is also a continuous data, and interest or inflation rate is also continuous data. Since the price of a stock can be $10, let's suppose, and it could be $10.3 as well. So such kind of data is known as continuous. And as we are discussing to calculate the standard deviation in the context of discrete data only. Therefore, the formula for calculating the standard deviation for a discrete data is this one. Let's come back to our numerical example of stock basket wander. Since we have already calculated the expected return of this data and stock basket wander, which was R bar is equal to 9%. This is our expected return. And the next phase asks us to find out the standard deviation of this stock, which is measure of dispersion or the risk factor involved if you are going to invest your money in basket wanders stock. So the formula was asking you to find out Ri minus R bar. Ri first value, possible value is in the minus 0.15, which can also be explained minus 15% return needs to be minus from expected return. The expected return of this stock is 0.09. So you can simply minus this one, minus 15 and then minus 0.09. The resultant value will be minus 0.24. So now in order to remove this minus sign, you need to square this out. This is the reason square has been taken to find out the standard deviation. Minus 0.15, then there is an additional minus 0.09 will give you minus 0.24 raised to the power 2 and then multiply by with relevant probability, which is 0.13. So let me explain once again with the help of another numerical value. Let's suppose we are trying to come up with this finding. The formula to calculate is this one, which is Ri minus R bar whole square multiply by with relevant probability. Ri in our case is 0.21 minus expected rate of return, which is minus 0.09, then whole square, this is actually 2 not 1, whole square Ri minus R bar, and then we need to take a square to it, then multiply by with relevant probability, which is 20 in this case. 20% chance is there, so 0.20. After plugging the data in this numerical in this formula for calculating the variance or standard deviation, we can simply multiply this and find out the resultant value, which is 0.0028. So this is the way how you can calculate the related value for each row in our case. So the first value, second, third, fourth and fifth. After calculating all the possible outcomes with the help of this formula, you are required to sum them up, and the final value of this column is 0.0172. Now we have realized the formula for calculating the standard deviation for a discrete distribution was this one, and we have arrived to, after calculating this factor for each row, we need to accumulate them up or sum them up. After summing them up, we can take the square root of this value to reach at our destination, which is to calculate the standard deviation of this stock. Now we have calculated this narration, and the resultant value in our previous slide was 0.1728. Now you are required to take a square root of this value, and the resultant value for standard deviation will come up by 0.1315. This sigma represents standard deviation of stock of basket wonder. Another way around, if you would like to have a percentage value, you can simply multiply it with 100 and the resultant value will be 13.15%. Now what does this mean? This 13.15%, or what is the meaning of standard deviation? This 13.15 represents the risk factor involved if a particular investor is going to invest his money in Basket Wonders share. Or we can also explain this result in this fashion, that there is 13.5% variation in the expected return of this stock if the investor is going to invest his money in this particular share. So let's say the limit for a particular investor to take certain amount of risk while he or she is going to invest his money is, let's suppose, 10%. So after calculation, if this result or standard deviation is greater than 10%, which is the expected risk of or the desired risk of the investor, then the investor decision will be not to invest his money in this particular stock. And let's suppose if there is another investor who is a risk taker and his risk limit is to take risk up to 20%, then this 13.1% of the standard deviation in the stock of Basket Wonder will be a good investment opportunity, and he will invest in the share of this Basket Wonder stock or the investment opportunity, because the 20% risk factor limit is quite higher benchmark for this investor, and this stock is actually having 13.5% of the risk factor. Therefore it could be a best opportunity for one investor, and same stock could be a bad investment opportunity for a risk averse investor. Now let us discuss the coefficient of variation, which is another measure of calculating the risk factor involved while you are going to invest your money in any investment opportunity, in share or in any other financial asset. What is the coefficient of variation? Coefficient of variation is ratio of standard deviation, as we have calculated in our previous example, which was 13.15%. It is a ratio of standard deviation of a distribution with respect to mean of that distribution. It means that it is a relative measure of risk. And how to calculate it? Mathematically, we can write coefficient of variation is equal to standard deviation divided by the expected return. In our previous example, the standard deviation was 0.1315. You need to divide it with your expected return of the same stock, which was 0.09, and the resultant coefficient of variation for Basket Wonder share is 1.46. Now let's explain what does it mean. It means that if there is 1 unit increase in the expected return of that particular share, the resultant increase in the risk factor or in the standard deviation of the stock will be 1.46. As we have explained that it is a relative measure of risk, therefore we can use the coefficient of variation in order to select between different opportunities available to invest your money in. Let's suppose we have another stock which come up with 1.21 coefficient of variation, and similarly there could be another stock C whose coefficient of variation could be 1.11. So therefore we can conclude that the Basket Wonder is not good investment opportunity, because there are other stocks available like stock A and stock B are available in the market whose coefficient of variation is quite lower than the basket wonder, like 1.12 and 1.11. If the investor is going to select amongst the different investment opportunity on the basis of coefficient of variation, then the investor's choice will be to select that stock for investment whose coefficient of variation is less than the other stock, because the relative measure of risk explains that with the increase of each unit in the expected return, there is less amount of increase in your standard deviation or risk factor. So lower the coefficient of variation, higher will be the return realized by that investor with respect to that particular standard deviation and expected rate of return. The combination of or the variation or ratio of the expected return and the standard deviation will be more feasible to the investor if the coefficient of variation is less than the other investment opportunity. Let us discuss now how to calculate the expected return and standard deviation if the data pertaining to the example is continuous in nature. The formula for calculating the expected return if the data is continuous in nature, like in the decimal places data, it starts from summation I start from 1 to n. Ri, similarly, this Ri represents the ith Ri, the return for the ith observation, and R bar represents the expected rate of return whole divided by n. This slash represents divided by n. N is the total number of observation. Like for example, if you would like to calculate the average marks obtained in a particular class, so the total number of student, let's say if the total number of student in the class are 10, you can accumulate all the marks of the 10 student, like R will be 1, 2, 3, 4 up to 10, and then whole divided by the number of student, which is once again 10, and you will get the resultant average value or the expected return of that class or expected marks of that particular class. Similarly, if you would like to calculate the average price of 5 different stocks, you can simply accumulate the 5 rate of return and whole divided by 5, and you will get the resultant or expected rate of return for that asset. Like let's take an example that assume the following list represents the continuous distribution of the population returns for a particular investment, even though there are only 10 returns. This data represents the 10 rate of return for a particular population, which is continuous because this is in decimal places like 9.6. Then this population was giving us minus 15.4 rate of return. Similarly, in the next year, let's say it was giving us 26.7% rate of return. The question asks us to calculate the expected return. So simply you can add up all these 10 values and whole divided by 10 will give you the expected rate of return. And similarly, you can also calculate the standard deviation for this population, assuming a continuous distribution. So this is your task, students, to calculate and use this data to calculate the expected return with the help of this formula, which is quite simpler and easy. Similarly, if we would like to calculate the standard deviation for this population rate of return, we can also do that with the help of this standard deviation formula used for continuous data. Here the slide changes that Ri, the specific rate of return, which could be like, let us take 9.6%, the first observation. So make two columns once again. One should represent Ri and another one should represent this expected return. You can minus Ri 9.6 from your expected return, which is R bar. In your previous step, what you have calculated. So Ri 9.6 minus the expected return, which could be any value, like let's assume it was 8%. So you can minus 9.6 minus this expected return, and then square both the values, and finally you need to divide them after summing all the possible returns. So in the same fashion, you are required to calculate R minus R bar for each observation, and after getting the 10 resultant value in your third column, you need to sum up them, and this final value should be divided by 10 as written in the formula. After minusing or minus each value from Ri related return, you can sum them up and then whole divided by n. This formula is similar to the statistical algebraic formula what you might have studied in statistics, just like x minus x bar, then whole square divided by total number of observation, and as well as you need to sum up all x minus x bar values, and then whole divided by whole taking under the root to whole algebraic expression will give you the standard deviation. Now note that this is for the continuous distribution, where the distribution is for population, and R bar represents once again the mean value for that population. This is the way how you can calculate the expected return with the help of this formula for a continuous data, and as well as standard deviation by using this particular formula. So dear student, this was all about the risk and return and how to measure the risk factor, particularly in this lecture with the help of standard deviation for discrete and continuous data, and as well as we can use coefficient of variation, which is a very nice and sophisticated measure for selecting the best investment opportunity. If you have any confusion regarding this phenomena, you are free to ask question on KCMS or on my registered email. Thank you very much for listening to this lecture. Good luck for the day. Allah Hafiz.